All right. We're going to take our Venn diagram prowess and attack probability with it. One of my favorite parts about Venn diagrams are the ridiculous things people make. Here's the Von Van Venn diagram. So all of these people were European. Von Traps, Von Dam, Von Trapp, Van Dam. All of these people were musical. Van Halen, Von Trapp. All these people were Vans, Van Halen, Van Dam. And this one's all of it, Van Morrison. Maybe that's too young for you. Or vice versa. So before we get there, I'm also trying to, before we jump into probability, I want to remember how to simplify some radicals because I'm going to attack you with them eventually. So let's try these out. I'm sure you can do this 12, so pause me, try them until you run out of options, and then unpause me. Go. All right, so we're simplifying. So this we want to break into perfect squares. You could do 2 and 2, but that's not helpful, right? This allows us to take the root of both pieces. Root 4 is 2, and root 3 is root 3. So that should be 2 root 3. Lovely. 10 stays outside. This turns into root 32, which I'm going to call 16 and 2, times root a squared. This is still 10. This is root 16 times root 2. The root 16 comes out as a 4, and the root 2 stays in. And root of a squared is just a. So this becomes 40a root 2. Right, here's 40. Here's a. Here's root 2. And with this mess, you can't simplify it. I think I put him in the wrong spot. Yeah, dork. These should have been switched. Sorry. So here, let's try this. Even if you're not super confident in it, let's give it a shot together and make sure we can get this out of it. All right. Well, 4 is going to stay there. I'm going to break up the rest. 27, I know, is what, 9 and 3? X to the 5th, I'm going to call x squared and x and x. And y to the 5th, I'm going to do the same. And root z is just going to stay in there. This root 9 is 3, so that comes out. This 3 is stuck in the radical. Square root of x is an x. Square root of another x is another x, and this lonely single x is stuck in the root. The same thing happens here. Square root of y squared is y. Square root of y squared is y, and square root of regular old y is square root of regular old y, and regular old z is still in there. So then this is your 12. This is your x squared, this is your y squared, and you're left with 3x, y, z underneath. Yeah. Alright, so I want you to be able to take what we did yesterday with Venn diagrams and apply probability. Here's a black bear with a concertina and a polar bear with a keyboard, and here's the intersection. It's a panda bear, both black and white, and also with a accordion, which is a mix of a concertina and the keyboard from the keyboard. Who has time for that? All right, and same with this, a Venn piegram. Very clever. This is the same piece that we were working with yesterday, but we found raw numbers. Right? We found that the total number in the club were 75, total number who played hockey were this many, 27 plus 26. Number who played both, we read it off here. Number who played neither were there. We figured out just the raw numbers, right? So we're going to take those raw numbers and apply some probability. So what's the probability that we pick somebody at random off a list of everybody that's in the club and we see that they play hockey? Well, there's this many, there's 53 out of the total in the club, right? So there's 53 out of 75. You divide and you get 71%. Cool. take that idea and try these probabilities. The probability that you pick somebody and they play both sports. They play at least one sport. And then this one, think about play both sports, given that we know that they play hockey. Yeah, try that. Okay, play both sports. Both sports is only the 27. It's these out of the total. So 27 out of 75, 36% chance. Play at least one sport. I don't care if they play both. Both is great, but if they play hockey, great. If they play tennis, great. If they play both, double great. So all of these, I think we said that those were 68 out of 75. So 68 out of 75, 90%, which makes sense because most of them are playing tennis or hockey. All right. So this one's tricky. That they play. I want the probability that they play both sports, given that they play hockey, right? This piece, given that they play hockey, means I'm not picking from everybody. I take the list that has everybody, and I find the portion that says hockey, and I just take the hockey part, and I read off the hockey list. So given that they play hockey I'm only looking at these. I don't care about those. I don't care about those. Given that I'm already looking in here, I know that there's 53 that I'm looking at. There's 53 that play hockey. That's given. And out of those 53, oh, hey, 27 play both. So 27 out of 53, 51%. Cool? All right. So, I like that. Think about it, Venn. Who could have sent me this? It's this guy's face, and he's calling him a butt brain. There's Venn, the inventor of the Venn diagram. So of course he wrote it. So 30 of y'all just signed up for next year's classes. Some signed up for physics. Woot! On the sign up for physics, woot, there are 19 names, right? So here's the physics. On chemistry sign up, there's 17 students, right? And 15 are on both signups. So we want to put this on a Venn diagram and find the probability of these happening. So let's try that out. All right. Well, the hardest part of this is building the Venn diagram. So I want you to try this without me. Read this piece, pause me, try to build the Venn diagram without me. Think about how many aren't on the physics or chemistry. Think about how many this in physics. These are 19, right? 19 is distributed amongst A and B, and nobody's double counted, right? Once you're displaying the data in here. Chemistry's sign up has 17, right? So think about that. All right, so we know that 15 names are on both signups. So I know that 15 are overlapped. Yeah. We also know that there are 19 in physics. So if there are 19 in physics and 15 do both, how many are left here? Well, it's got to be 4, right? Because 4 and 15 make the 19, right? And what about in chemistry, right? Chemistry is all of these. So chemistry's got 17 students. So 17 means that we're going to have 17 in here. 15 do both, so we've got to have 2 there. Yeah? Then what about this? What about none? Yeah? Well, let's see. We got 15, 17, 18, 19, 20, 21. So there's 21 here in total. So how many are not physics or chemistry? Well, 9, right? Because there's 30. There's 30. 30 in total. So if there's 30 that are either physics or chem or both, then 9 have to be non. Is that right? Yeah. Here, let's get rid of my scribble. So there's our Venn diagram. That's the hardest part, right? So let's read it. That's the easy part. That's what we did yesterday. The only easy day was yesterday. Both subjects. Yeah, you're a super nerd. You're taking both subjects. What's the probability that we just randomly select from this 30 and we get somebody who's doing both? Well, 15 out of 30, right? 15 out of 30. 15 are doing both out of a third, out of total, so 1/2 or 50%. Right? B, the probability that at least one of the subjects is you're enrolled in one of the subjects. Well, these are physics, these are chem, and these are both. They don't care if you're overlapping, right? If this is a university, they want to know you're taking physics or chem. If you're taking both, they're not going to be like, oh, this slagger is taking both. No, they're going to be happy about that. So add these up, right? Add those up. And at least one of the subjects would be 4 plus 15 plus 2 over 30. So 7 out of 10, once you simplify that, so 70%. All right. Probability that they're taking physics but not chem. Well, physics but not chem is here. Right, so 4 out of 30. So you're just reading it off the graph. 4 out of 30, 2/15, whatever fraction that is, or decimal that is. And then taking exactly one of P and C. Well, exactly one means you're not overlapping. You're either taking chem or you're taking physics, but not both. So 2 are doing only physics. 4 are taking only physics. 2 are taking only chem. So 6 out of 30. 1/5, 20%. Cool? Cool. All right. If you need more practice, you can try this one out with me in a second. If you'd like, though, your home learning looks like this. The hardest part is drawing the diagram. So don't skimp on the practice and just look at the answers. Be like, oh, I got it. Figure it out the first time. Figure it out now, right? Fight for it. Instead of just like, yeah, I'll get it next time. Yeah, practice. That's this piece. There's solutions on there. If you're not sure, let's try this one last one. My head out of the way. So suppose A is the set of all factors of 24 and B is the set of all factors of 28. Here's the union 1 through 28. This is everything is in 1 through 28. Find this symbol is called the intersection. It's the and. Cool. And so we're going to illustrate it on a Venn diagram. So find all the factors of 24 and all the factors of 28. Well, here's all the factors of 24 and 28. Where are they? Where are they? There we go. So these are the factors of 24. Here are the factors of 28. Things that multiply to 24 multiply to 28. And so the intersection is the overlap. So 2 is in both. 4 is in both. 1 is in both, right? So 1, 2, 4. Great. So illustrate this in a Venn diagram? Sure. There's all the numbers. Here's numbers 1 through 28 that aren't factors of either. They're all on the outside. Here's the factors of only 28. Sorry, of 28. Here's the factors of 24. And here's the overlap of both. All right? So find this is the union. It even looks like U. Means the numbers that are either in here or in both. Right? It's the union. So these pieces, 1, 2, 4, all of the ones within here are factors of one or the other. Cool? All right. I'll see you guys on the next round. Bye.